Welcome to the lecture series on phase diagram for refractories. I have completed the first lecture series on designing and failure analysis of refractories and recently started the second lecture series on natural and synthetic raw materials, where 43 materials will be discussed. Before starting the material lecture series, I believe correlation with high temperature reactions through an understanding of phase diagrams will provide an exact flavor of the subject. In this backdrop, I have planned to start third lecture series on phase diagrams for refractories that eventually help to correlate the importance of material selection and their impact on the refractory properties as well as performance during steel processing. If we pick up different oxides, there are several possibilities for the formation of binary and tertiary phases in refractory. It may be during refractory processing or in situ during steel processing. Here I picked up very important 5 binary and 3 tertiary phase diagrams of different oxides and major constituents for refractory sectors. Despite these essential phase diagrams, understanding the iron carbon phase diagram provides the importance and the requirement of different grades of refractories. In the future, I will discuss 10 lectures on the following topics. I have given a brief on why I want to emphasize these particular topics. For example, necessity and definitions. I want to discuss why and how we will concentrate on it. Alumina silica system, it will help to synchronize temperature for processing of alumina and mullite bricks or while silica reacts with pure alumina. Alumina magnesia, essential while manufacturing spinel brick or in situ reaction during steel processing, and there is reaction in between the alumina and magnesia. Similarly, magnesia chromia is important during manufacturing of magchrome brick. Magnesia calcea, essential for dolomite brick processing. Magnesia silica. This information will give the reason and what happens when silica interact with magnesia at elevated temperature. Similarly, while any impurity react with the pure system, what happens? These 3 diagram will describe that one. Eventually, iron carbon diagram is essential since steel properties depend on phase, microstructure and constituents, and different grade of steel manufacturing process are different, and because of that we need different class of refractories. Despite these 3 lecture series, I will float 4th lecture series on testing of refractories by standard protocol like ASTM, which is very essential for industry. All details can be found in this book and send mail for further discussion. In the next slide, I have highlighted the probable binary and tertiary phases from different oxides. These are the prime oxides. If any impurity react with this, it may form different binary and tertiary phases. Here we can see the importance of the map. A map helps how us get into the Department of Ceramic Engineering at NIT Rourkela. Google has already drawn the map to make life easier. There is no need to draw such map. Google already did it, and with some basic features and concepts. Similarly, I will emphasize how we can use such existence phase diagram like this for raw material selection, selection of refractory processing temperature, reason for corrosion during application. Please keep in touch by subscribing. Although I am overloaded, I hope to manage time to upload all lectures. Thank you for your patience.